So in this video, we're going to be talking about normal map baking. It's set up to be somewhat of a boot camp. So we'll go over all the topics listed and I will supply you with some exercises that you will complete to kind of guide your way through learning this really complex process. Normal map baking is probably one of the more technical, artistic things you can do inside of game development. A lot of rules apply, and it forces you to model in very specific ways. So, why don't we go ahead and just get into it? And I'll start out by going through the normal map baking process. So, the very first thing I like to do whenever I'm getting ready to start normal map baking, let's say, and you can refer to this outline linked to go to any topic that you might need a refresher on, but I'll be following each bullet point in order. So I'm going to go ahead and bring this off screen. And the first thing we're going to do is we're going to get set up by duplicating our mesh. All right. So let's say that this cube right here is our original model. Let me go ahead and hide some of these other things. This cube right here is our original model. It's the shape, the main shape of the model that we're making. Okay. So what we're going to do is we're going to take this shape right here and we're going to, let me hide the original, make a low poly bake and apply this type of normal map to it, or something somewhat close to this. During my modeling process, I might not get the exact dimensions of all this stuff exactly right. So how do we do that? Well, here we have my normal map displayed. If I press 5 on the keyboard, then I go to no texture maps. I have a normal map applied to my shader on this cube looking object right here. And you can really see that we're getting some really nice detail. It's really popping off the model. Our edges are beveled and smooth. That's hard edge with no normal map. That is our smooth edges with a normal map. And we're just getting some really nice soft features, really nice normal maps baked onto this guy right here. So that's our end goal. All right. So I'm going to go ahead and hide this and bring back my original cube. The first thing we're going to do inside of my outliner, let me bring my outliner in right here, is we're going to set up some models so we have a non-destructive workflow. We don't want to start making this cube low poly. We don't want to start adding support edge loops to this to make it high poly. We want to have our original shape on hand for us because it's going to help us save some time during the workflow process. So what I'm going to do is I'm going to rename this cube. I'm going to call it Orig Mesh 01. Let me spell that correctly. And I'm going to duplicate it 2 times. I'm going to call this High Mesh 01 and this Low Mesh 01. And I'm going to apply a separate layer for each one of these models here. For my original mesh, I'm going to put it on my original layer. So now I have a layer controlling my original poly. For my high mesh, we're going to apply that to my high layer. So you can see I can hide and show that. And my low mesh, we're going to put on my low layer. All right, let me move that down. And let me get them correctly in order. All right, so we have original mesh that we're never going to really touch again. This is going to be if we make a mistake making our high poly or make a mistake making our low poly. It's always nice to have our original mesh on hand. We don't want to destroy it. And my high mesh, this is what we're going to add my support edge loops and do some sub-D modeling on. And my low mesh, this is what we're going to get rid of some of the topology on, bring the triangle count down low, UV map, and this will, in the end, be our game model that we'll import into different game engines. All right. So why don't we go ahead and start the high poly process, taking this original shape and turning it into a high poly model. All right. So I'm going to go ahead and make my high poly visible. Now, before we get into actually making this high poly, let's talk about some rules with high poly modeling, some hard surface high poly modeling inside of Maya that specifically pertain to getting clean normal maps. All right. So what I'm going to do is, for the sake of showing before we get into the whole process, I'm going to go ahead and group these meshes and call it tutorial, because this is what I'm currently working on in this tutorial. I'm going to hide that, and I'm going to bring back my full example bake. And here you can see I have my high poly that I originally started out with, that I baked that first normal map from. All right. So why don't we talk about some specific rules here? So what we're going to do is we're going to go through each outline, and I'll show picture examples of each, and I'll show how they pertain to the model in question. So the first thing we're going to talk about is edge smoothness. So I'm going to zoom in here, and we have two different models of a gun sight right here. On the left, we have a realistic version and pertaining to just the edge thickness. See how our edges along this top part are really sharp? That's kind of what the metal is going to look like in real life. And on our functional side, we have kind of this ballooned out edge, something that's a little bit more organic and inflated than what we might see on an actual gun sight in the real world there. So why does this matter? Well, let's zoom out and look at this object from a distance. On the left, okay, we can still see that nice beveled edge on our normal map here on our gun sight. And even there, we still see the nice little balloon side. Let's zoom out a little bit more. And we can see that our edge is starting to we can't really see the nice bevel as we zoom out. But we still see that nice bevel on our functional sight. And then as we zoom out even more, I'll try to zoom out so the picture doesn't get too pixelated. We're starting to get jaggies, and we're losing the normal map information. But yet our functional, with our inflated organic edge, we're still seeing a nice bevel. And then, really far away on this really small object, we don't even see normals. They don't even matter anymore. We just wasted our time making those really sharp edges. But on our functional sight, we're barely visible, but we can still see that edge is smoothed out and we got the nice bevel. So if we go all the way to the top, even though this might look more realistic up close, the functional bevels right there are what we're going to kind of shoot for. So how do we achieve that? All right. Well, with my high poly model right here, I have some support edge loops made around the model itself. And notice how they're not super tight. They're kind of been pulled back a little bit, right? They're not so cramped together. So when we make our subdivision smooth right there, it's going to give us these nice smooth edges that you kind of saw in our example. And whenever I'm recreating this high poly, I'll be sure to point out that making those really smooth edges in action for us. All right, so why don't we see what's next on the agenda? So sloped extrusions are a pretty big deal. So what are sloped extrusions? Well, let's bring up another picture reference. So we have two different high poly models right here. We have this cube with another cube extruded out from it. And look at that really sharp, it's like 90-degree angles between this face and then that perpendicular face, and then another 90-degree angle between this front-facing face. So it goes 90-degree angle, 90-degree angle, straight out. But on the right side, we have this trapezoid-looking shape. And you're asking, well, if I just want to bring out a cube from another cube, why on earth would I make a trapezoid? That doesn't look like a cube. That's a trapezoid. Well, let's see how it translates out to our normal map. So after we bake our normal map, this is what we get from that hard 90-degree angle. We barely see the shape of that cube right there. We just, the projection, the normal map projection, just can't see all the nuances of maybe, say, on the trapezoid shape right here. Look, we get a nice normal map. We can definitely see that another cube is coming out of it. And this is the end result. This is on our game model right here. That trapezoid, all of a sudden, looks like it's more like a square again. Normal maps are kind of weird. They need to be able to see the detail in a front-facing way. So that might be a little confusing right now, but as I build my high poly, I'll get in more depth about that topic. All right, so intersecting geometry, what is that? Well, whenever we have, let me bring back my picture right here. Whenever we want to intersect two separate pieces of floating geometry, on the top left of this image, we see that my little cube is clipping through my larger cube, but on the right side, my smaller cube is floating right above it, and you can see some space in between the two cubes. And this middle picture represents my in-game model. Notice how in my in-game model, there's no negative space. It's completely flush from the little cube to the big cube. So with our high poly on the left side having the intersecting clipping geometry, we get no shading errors on a normal map. But on the right-hand side, remember how this floater is just right above it hovering, and we can actually see some space in between. If we zoom into that, look at this normal map error we have right here. There's like no information whatsoever, and that looks pretty bad. So if we look at my example of my high poly right here, this is the difference between non-intersecting. See how we have some space in between? What we want to do is we want to inset that shape right inside there. And now our low poly is going to know what to do whenever it intersects at the two different cubes there. So that is intersecting geometry if you're using floaters. Decimating is it's kind of a retopology tool popular in programs like ZBrush. I'm just going to gloss over it real quick because we're not really focusing on any particular one package of software. But decimating means taking a high poly model with millions of polygons, something really smoothed out, and transforming that or retopologizing that high poly with a bunch of triangles, and it only draws the necessary detailed information at all the little physical details. So basically, it takes a high poly model full with a bunch of grids, small little squares on the grid, and gets rid of all the unnecessary lines and only makes triangles that captures the high detail information. Basically, you're just retopologizing your high poly, and you're taking a model that could be 5 million polygons down to something like 200,000, which is useful if you want to import a high poly model into something like Maya and then use that to bake down off of. Maya doesn't really handle millions and millions of polygons very well on most computers. So that's decimating. Floaters are another interesting topic here. It's a really nice little tricky way of faking detail. So if you looked at this originally, you might have thought that this object right there was flush with this one, our cube and our floater. So what's going on here? Well, as you can see, my floater is riding right on top of my model. It's not intersecting, but you said a second ago when you have separate pieces of geometry, they should intersect. Well, what we're going to do with this piece of geometry is we're not going to physically model this ring right here. This ring is just going to be baked down to the normal map. So notice how our low poly model has geometry for this piece of floating geometry, but on this side, this piece of floating geometry is just a flat face. But yet I was still able to manage to capture its detailed information. And that's possible because when we bake from a normal map, we only bake from maybe one direction, like facing straight on at the face like this. And from just the way we're looking at it, this looks seamless for all intents and purposes. So that seamlessness from this angle or from this perspective gets translated into a nice, smooth, normal map. And there's a few caveats to that. First of all, it can't be too deep of a detail. Let me go a center pivot. don't make it so deep like that. It still needs to be somewhat flush. Secondly, see how we have this outside ring of faces here? Well, these faces need to kind of extrude off of your floating detail and create this nice flat border with uh, no more extrusions coming off of it or, inset detail. It's just a flat kind of border around our shape here. That ensures a nice, easy transition between our floater and the flat cube right there. So we'll get more into that, and I'll show that in action when we get into the workflow process. And here we have some photographic representations of this. Here we have that same kind of detail, like a ring on an inset into a face right here, when all along it wasn't modeled. It was just a floating piece of geometry coming off of our model. All right, what's our next rule? And normal kit bashing, let's see, what does that mean? If we take to this website, we can actually combine different normal maps together inside of Photoshop. And there's a very specific way here, but I won't go to it in detail, but you can actually take bakes or details like maybe just this, if you just clip this detail right here, you can actually copy and paste this normal map all over the place inside of something like Photoshop. But there's a very specific way to make sure that we're getting overlays correctly right. And you can see in this GIF right here, the correct way versus just an overlay filter. The overlay filter muddies up the normal map, but the detail-oriented method, we can see the normal map nicely coming over our details right there. So if you're more interested in learning how to kit bash with normal maps directly inside of Photoshop, you can check out this link that I've provided there. All right, so those are basically all the rules we need to have for high poly modeling. So why don't we go ahead and see them all in action here. So I'll take this over here and I'll hit up each and every single one of those topics as I'm making my new normal. All right, so I'm going to hide my original model that we started out with. I'm going to expose my tutorial meshes, and I'm working on my high mesh 01. Excuse me. I'm leaving my original mesh alone, and I'm leaving my low mesh alone. So why don't we get started making my high mesh. All right. So the first thing we're going to do is we're going to, let's see, maybe why don't we make that floating piece of geometry real quick. All right. We're going to float that ring on the side over here. So I'll go to create, and I'll start out with a cylinder. I'll rotate it down 90 degrees. And I'm not going to make it a complex shape as the other one, just for the sake of time. All right, so why don't we just scale it down to something more our size here. And since we're going to be sub-D modeling, I'm not going to worry about starting out with too much geometry here. But I am going to start making some edge extrusions. And there's a few ways we can do this. We can just edge extrude the whole time, or we can insert some edge loops here and then pull them up. So there's our ring right there. I'll insert another edge loop on the outside, bringing it in. We're starting to get something here. And if you see how we're terminating to a bunch of triangles here? If I try to do it, insert an edge loop right here, our insert edge loop tool doesn't quite work. So instead, we're going to select all these triangles, and we're going to extrude like so. So now I have using the extrusion tool, I kind of have some geometry in here that I can start working with. And I don't know, I'm just gonna make a shape. All right. So what I need to do now is I need to go on the outside of my edges here, And I need to create that flat border that just extends outwards. And I need to scale this down. We don't want to clip over our original shape here. We want to keep it self-contained on this flat face. Floaters like this only really work on flat geometry. I'm going to make it not too deep. Remember, we don't want something too tall. And there we have a nice little ring coming out. If I want to add some more definition, I can use some support edge loops to really cut this shape in, like so. So now when I sub D it, I get somewhat of the same kind of effect we had going on earlier. Maybe make something out there. All right. So for all intents and purposes, we just made our floater. I want to try to get it as close to that surface without the two pieces intersecting. And there we go. There's my floating piece of geometry. And I'll call this floater item outliner so I know exactly what's going on there. All right. So that's perfect. We'll move on to maybe making that little button in our back. And this will be an example of when we were talking about sloped extrusions. All right. So I'll select these faces back here, not that one, and not these. And I'm going to extrude my face. And rather than just bringing it straight out, because I don't want another piece of geometry just, being built off of it, I'm going to create a button on the back of my cube that's only captured in my normal map. So if I do that, there's my button, looking perfect, right? Well, look what happens when we look straight on at our cube. My button has disappeared. I mean, we can see it from the sides, right? Because we can see that these faces coming out like so. But remember, our normal maps bake straight on from this perspective. And you'll see more why that occurs when we start talking about projection cages further down our process here. But all you got to know is when you look straight on our detail right now, our cube is lost. So what we'll do, or our button rather, I'll just select all these verts here, and I need to give it a slant. And now look what happens when we look straight on. Hey, my button's appearing. Perfect. So that looks pretty good. I just want a little button coming off that I want captured inside my normal map. And again, don't have it coming too far off of our high poly model. All right. So what we have now is our original piece has this cube coming off of it. What we want to demonstrate, let's go ahead and delete that. And why don't we act like that never existed there? Why don't we say, let's just make this face flat again. I'll use my append to polygon tool, like so. What I want to do is I want to have two pieces of intersecting geometry clipping through each other to create another shape. So we'll just recreate that from scratch. And there we can kind of see what kind of shape we had before. All right. So I want this cube to kind of extrude out of my game low poly model. And I want to show us a quick little method. Instead of using support edge loops, we can actually bevel all the edges of this cube right here. So I'll go into component mode just so I select the edges right here. So I'll select the model, go into component mode, and now we can only select the edges on this particular object. If we go to mesh, edit mesh, and bring up our bevel, okay, well now we have, I don't know, something you would play a board game with, a die. Well, we're going to tweak these settings here. Maybe let's do 0.2. That's still too much. 0.1, still a little too much. Let's do 0.05. That looks pretty good. And then we're going to add some segments to create that nice bevel. And now we have our fat organic edges at work here for us. So now we're just going to inset it. See how these beveled edges, I'm just going to sink right into my model here. I want this to be kind of a flush 90-degree angle. Remember, we don't want it floating outside of it, and I kind of don't really want to capture this bevel, dipping into my model. I want to go just all the way into it. So now what we need to do is, I think we're done there. We got rid of that cube that was coming out of our original mesh, and now it's being covered by this high poly cube that we just made with beveling our edges there. And I'll call this clipping mesh because it's clipping into a high poly there. So that's our intersecting geometry at work for us. All right, so we've covered floaters, we've covered sloping geometry, and we've covered intersecting geometry. All right, so now let's talk about edge thickness. All right, edge thickness. Well, why don't we go ahead and start putting in some support edge loops to make this guy a really nice high poly model. Because right now when we press 3 to go into sub D mode, we get this lumpy whatever this is. So what we're going to do is we're going to use our insert edge loop tool, and here's our edge thickness at work. I'm going to do it wrong first. I'm going to create some really sharp edges here. All right, so if I press 3 now, ooh, that cube, it's got that really nice kind of sharp edge. It still has a little bit of a bevel going on, but that's really sharp. That's like almost like a piece of metal sharp. Remember though, that's wrong. That's bad because as we back away from it, we can barely even tell there's a normal map there anymore. We can only really tell if we kind of zoom in close. So what we'll do instead is I'm going to double click these edge loops and just move them back. Give my support edge loop some room to breathe, like so. So now, even though they kind of look not as sharp, as we zoom out, look, we can still see those nice beveled edges from a far distance. So we're going to kind of continue with that motif all the way around my cube here. I need to put another support edge loop there. I need to come down here and put one right there. I need to go to the front of my high poly and put one there. There we go. So now my cube looks like it has those sharp edges all the way around, or those beveled sub D edges all around with the support edge loop method. But we got two details that are kind of just losing their mind here. We're not really getting that sharp button look anymore. It's turning into just a weird marshmallow shape coming out of it. And our cylinder is completely messed up. So why don't we see how we can fix these shapes here. I'm going to start out by support edge looping my cylinder here. And we have a problem here. Good support edge loops need to lie on either side of my cylinder. But yet, when I can insert an edge loop just fine on the shaft part of my cylinder, but on the other side, where the cylinder meets the face of my cube, I'm not getting a ring around my cylinder here. Instead, I'm just kind of getting something like this. No bueno. So how do we do this? Well, we're going to get creative. So what we need to do is we need to create a ring around the cylinder that's just seamless all the way around. So what I'm going to do, and this is going to seem crazy, I'm going to select my original border edge loop of my cylinder here. Notice how I had to make sure and double click a few times because it's not a flush topological edge loop. What I'm going to do now is I'm going to scale it up. Maybe some of you guys see where I'm going here. But now I can take that first support edge loop I made on the shaft, go into my move tool, hit V on the keyboard for vertex snap, and snap it flush with the edge of my cube there. Now I can insert another edge loop on my shaft, and look what we got. We have a nice perfect edge loop going all the way around my cylinder, and we have a nice support edge loop around the shaft of the cylinder. Pretty nifty little trick. And the edge here, there's another little caveat there that we can do. So why don't we go ahead and put one on this end of the shaft. Remember, good support edge loops have a support edge loop on either side. So we're not quite getting a nice circular edge loop going on here. Well, that's whenever you just select all the faces of your cylinder, making sure we didn't select any unwanted faces. And I'll do an extrude, hit my scale tool, and just scale from the center. And there we have a support edge loop working for us right here, just by extruding our faces inward from the center. All right, so now my cylinder has some nice edge loops, and every once in a while, maybe zoom out to see how your edge thickness is working from a distance. That might be a little too sharp on my front of my cylinder there. So if I want to make this edge loop a little bit less sharp, I'll just double click it and just scale it from the center again. So now when we zoom out, great. My normal maps are looking like it's going to be really, looks like my normals and my edge thicknesses are really going to pop from a far distance. All right, we have one more thing to do, and that is fix my little button on the back. So that's easy. We just use the same kind of support edge loop stuff we've been using, like so, just all the way around. Like so. And there we go. Well, we have a little bit of an issue right there. So remember, support edge loops on either side. If you forget to put support edge loops on either side, then you start getting like this little pinching artifact right there. But we can fix that by putting a support edge loop on the right side there. And don't forget the other side. Now that pinching is gone, and my little button is now staying a little bit more rigid. Oh my goodness. We've destroyed the roundness of my cylinder here. Well, never fear. We're going to use a method. I don't know if this is the correct term, but we're going to tie off our support edge loop. We're going to terminate our edge loops before they make it all the way around to my cylinder, creating this crease right here. So to do that, I'm going to use a modeling tool, target weld. You can find that in our modeling toolbox right here. So target weld allows me to select vertices and just drag and drop them to merge them. And we're going to terminate these edge loops into little triangles right on the support edge loop around the border here. Notice we don't terminate it right on the edge here. We're going to do it right before the edge. We're not going to tie them off like so. It looks like I need to put one more edge loop right there. Nope, let me undo that one. Go back into target weld. And I don't know, I just call it tying off because it looks like you're just taking these edge loops and tying them together. So, not quite finished yet. There we go. So they're tied off. Now that allows us to double click the edge loop on the other side of my tie, going all the way around here. Hold shift, right click, delete edge. We'll do the same up here. And don't forget to delete them all the way around. So we'll double check and make sure. Okay. We'll double check my cylinder, looking good. Oh, and looks like my button looks pretty good too. Tying off my edge loops allowed me to keep that hard rigidness. I still have my support edge loops like right here and right here. But yet, since we tied them off in the back here and deleted the edge loop going towards the cylinder, my cylinder is no longer creased. So great. Now we have a nice high poly model. All right. And you might be tempted right now to go ahead and put a mesh smooth on this. let me just go ahead and smooth it. I really like it. Well, what happens if you need to go back and make, changes to your high poly? No bueno. You've just destroyed the topology, and getting it back to its original state like this would take a long time. So we're just going to let our high poly mesh and all the floaters and all the intersections, we're not going to sub D anything right now. So we'll just select everything and press 1. And for all intents and purposes, I'll just group my high poly all together like that. For all intents and purposes, I've just made my high poly mesh. Okay? So I'm going to take this time now to save. I'll call this tutorial 002. Gotta love iterative saving. All right. So let's see. Let me bring up my channel box again. Now I can hide my high layer. Now I'm going to use my layer tool over here to bring up my low poly. And we're going to go over some of the rules of making a low poly mesh right here. All right, so there's quite a few more rules, quite a bit more finicky rules with building a low poly mesh than with the high poly. Since our low mesh is what the normal map's going to actually bake onto, we have to be even more careful with how we build out this particular model. So to exemplify some of these rules, I'm going to go ahead and hide my tutorial models that we're working with. I'm going to bring up this gradients and normal seams example that I got working with. All right, so I have 3 cubes right here. My high poly mesh right there, and my low poly that's correct with the correct kind of gradients and UVs, and just an abomination of a cube here. All right, so let's bring back my outliner, and let's look at normal gradients. So harsh gradients on normal maps introduce subtle artifacts on real-time models. Let's take a look at that in action. So why don't we examine the wrong mesh first? So let's look at this guy right here. What we see is all of our normals are smoothed. And if we bring up my texture editor, all the UVs are connected. That looks like a pretty typical UV map for a cube, right? So why is that wrong? Well, we'll get into that to a second. The main thing that we need to look at is these terrible shading errors. And they would be fixed if we just put a harden on our normal edges right there. But let's say we just left them soft like this. What kind of normal map would we get? That's the kind of normal map we would get. Look at these weird rainbow gradients that we have going on right here. I mean, not very good. And how does this translate to our game model? Well, here's that same cube in real time. It looks pretty good. We have those nice beveled edges here, but it looks like we have like some dented metal, like you dented a piece of aluminum and you try to flatten it back out, but no matter how much you flatten it, there's always going to be evidence of these little dents here. That's what reminds me of these little subtle artifacts in our normal maps here. We have a highlight right there, then we have like a depression right there. Either way, it's just shoddy work here. So there's our gradients right there, and all because we had these horrendous shading errors on the sides of my normals there. So what do we do to avoid that? Well, the best things you can do are to put a harden on your model. And this is just generally speaking, there's going to be lots of situations in the future where it's going to be a tough call to make. But for all intents and purposes on this cube, just to show gradients in our normal maps, we don't have the same kind of normal shading errors over here. And our UV map over here, all of our faces are separated into their own UV island. So here's a UV island just floating around. Every face has its own island. That might seem like some tedious UV working, but this is the result of the normal map. That looks pretty good, right? And here it is in real time. No weird dented tinfoil aluminum highlights and dents or whatever. So that's something to keep in mind. Hard edges are really nice for hard surface modeling, such as this cube right here. And really, this rule mainly applies to hard surface modeling. Some organic normal maps, you're just going to have gradients due to the nature of organic modeling. But mainly with high poly modeling for environment artists, you're going to want to pay close attention to gradients on your normal map, because you don't want that. This is what you want to see for the most part. Now, you can get away with some very light gradients here and there, but I mean, this is just too far gone. There's no coming back from that. Now let's talk about another reason why hard edges and separate UV islands are very important. I'll give some photo examples up here. So let's say that we took this cube right here and we hardened it, and we have no more bogus, horrendous shading errors going on. It's hardened. We should get some really good normal bakes, right? And this is the UV map we're keeping. We're keeping this upside down T. So let's see what the normal map. Wow, that looks a lot better, right? We got rid of all those bogus gradients that we see right there. Now everything looks flush. It pretty much looks like this, right? The only difference is all of our UVs are still connected into one UV island. So, I mean, and if it was rendered, it should look exactly like this, right? Well, here is that same T with the nice flush normals, one UV island, no gradients. Everything's perfect, except we start getting seams. Well, where are these seams coming from? Why are we getting seams now? Everything should be perfect. Well, here's another rule of thumb for all you guys out there, guys and girls. Anytime there's a hard edge, a hard normal on an edge, let's say we have this particular edge right here. I'll just put it as simply as I can. Here's a 90-degree angle, right? It's got a hard edge on it. When our normal gets projected from this face across to that face, the gradients that we were talking about earlier rear their head again, and it's trying to draw their normals at the same time, overdraw their normals onto each face. So this face is kind of drawing its normals across the hard edge right here, and this face is drawing its normal across that edge right there, and they're colliding right on this edge here, and the result is this hard blue line. You see that little blue line right in the middle right there? It's because they're overdrawing each other. Looking where we don't have gradients or these seams in some places. Like this edge looks fine, right? It's just this edge that's messed up. Why is this edge fine, and why does this edge have a crease in it, that seam there? Well, all the edges that are not connected, let's say all the border edges around this model right here, look at those nice normal fall-offs. They're just doing their thing. They're not harming anybody. So any edge on our border edge in our UV island gets drawn correctly, and we don't see a seam. But as soon as we have two edges defined by, let me get rid of some of these up here, defined by this 90-degree angle right here, that's when we start having these creases occur. So the rule of thumb is anytime you have a 90-degree face, you got, and this is the correct mesh, and let's bring up the texture editor for it, you got to give it its own UV island. So anytime you have hard edges, there's hard edges, and over here some hard edges. Anytime you have hard edges, you have to put them in their own island. And at some point I must have, there we go. So that's why all of our islands, or all of our faces, are on their own UV island. So we don't get any seams like we see right there. And of course, I'll be talking about that when we UV our low poly that we're going to make in a second. It's kind of a hard concept to understand at first, but anytime you see a 90-degree angle, you got to give it a hard edge normal, and you got to make sure it's not connected to any edge right here. All right, that's just the rule. And we can see that this edge right here connects to this edge right there, and both of these edges on these islands are going to get plenty of room to get this nice kind of gradient going right there. That's what gives it that nice beveled edge. And each edge right here are going to get their own space in the UV to get a correct bevel gradient going on. All right, I'll quit harping on it. If you don't quite understand it, hopefully whenever I start making my examples, you'll see how the workflow goes in relation to the hard edge and UVs rule. All right, mirroring UVs. Game models have textures that can take up to gigs of information, just huge texture files. So the more information we can put onto a UV, one-to-one UV space, the better. The larger our islands, our UV islands, the more detail we can put on each face right here. All right. So that in that regard, it's always better to work with symmetrical shapes. So what you can see in this picture right here is the highlighted faces are just symmetrical from right to left. I just mirror duplicated my model. And there's another caveat to that. Whenever you duplicate a mesh, the UVs are going to lay right on top of our existing one. So our two mirrored meshes are going to share the same UV space for their shapes. But with normal mapping, you don't want to leave these overlapping faces or overlapping UV islands on top of one another. You want to move them over one unit to the left, right, top, down. It doesn't matter, because this one-to-one space, one-to-one space right here, is repeated into infinity to all the other quadrants inside of our texture editor. So we want to maximize the amount of texture density we have for all of our UVs here. So we duplicate and make symmetrical meshes, so we can basically mirror our textures from right to left. And with normal map baking, you have to make sure that your mirrored UVs are not laying directly on top. And I have a script for us that allows us to do that. It's one line of code, very small, and it does the job pretty well for getting that effect going. So why don't we talk about waviness and normals next? So what is waviness? Well, why don't we bring up some pictures to display it? All right. So waviness mainly occurs on cylindrical or round objects whenever we're doing our high poly modeling. And what we see right here is our high poly is pink, our low poly is gray, and we can already see the pink clipping through our gray. So our high poly is clipping through our gray, and that's because we don't have the geometry to correctly, you know, suggest this round shape. Notice how this hexagon just can't match the topology of our high poly completely organic shape right here. So we get these, intersections and these little peaks of the high poly peeking out from our low poly peeking out from our high poly. So what's the result of this kind of intersection of our high and low? Wavy normal maps. So notice how the tip of my cylinder has like these waves going on. So what's the solution here? Well, more often than not, adding more geometry to your low poly is going to help us minimize the waves. And notice here, we have just a simple cylinder that you're used to seeing, and all we've done is add divisions every other line there, and we basically added twice as much geometry to our low poly. And if you can swing it after you bake your normal map, you can even delete this edge, that edge, that edge, because in this situation, deleting these edges is not going to mess with our vertex count too much. So our UVs are going to lie exactly the same. But that's a case-to-case basis. All you need to know to get rid of waviness, to get perfect bakes, you're going to have to add more geometry on cylindrical or round objects, such as this, like on the end of a gun barrel. You're just going to have to add more geometry to your low poly mesh. All right, so let's get rid of some of those examples. And you can see we're already going to have some issues. Let me get rid of that and bring back my tutorial image. We're already going to have some issues with my high poly there, you know. So we're going to have to, when we make our low poly in a second, we're going to have to figure out how we can add some more geometry, because we're already getting that effect going on right here. See my high poly and my highs and lows are just intersecting already. Or actually my low looks like it's totally engulfing my high. And that brings us to another good point. See my edge right here? I'm having trouble displaying that. For this, I think I'll turn on wireframe on shaded. There we go. My edge right here is not correctly corresponding to the edge of my cylinder. So that brings us to our next topic in the outline, proper edge placement on retopology of low poly meshes. So I'm going to go ahead and lock out my high. All right, so I have my high locked down. Look at my edge of the cylinder right here. It's just nowhere near. Here, this is a good angle from that. So there's my rounded high poly edge, this black line right here. It's just nowhere near. My low poly edge that I have selected is nowhere near my high poly. So if our edges aren't perfectly aligned, and let's show another example. Let's say my edge was like kind of out here. My high poly has like this nice beveled edge going down it, but my low poly is just off in the middle of nowhere near the correct edge that it needs to be on. So whenever you're retopologizing or you're finalizing a bake, right before you finalize a bake, make sure for the most part your edges are lined up. And that's where this workflow comes in handy, because if we're basing our high poly off of our original mesh, this guy right here, if we're basing our high poly off this original mesh and we're basing our low poly off the original mesh, our edges are going to already be in the right spot, because we're not retopologizing. We're just using the exact same original mesh, and the proportions and the edges should already be lined up for us. That's why I like duplicating my original model at the beginning, because it makes my low poly creation that much easier, because, you know, I don't have to worry about edge placement anymore. And let's see what's on the next on the docket here. Triangulate before you bake. There we go. So that's just a simple thing to cover. Before you bake your, let's say this is our low poly. Before we bake our low poly, we're just going to go to mesh, triangulate. All right. All game models get triangulated whenever they're inside of an engine. So even if you didn't have a game model with triangles already making the bulk of it, the game engine will triangulate for you. And since there's issues between how some game models may triangulate differently than other, or how some game engines triangulate differently from other game engines, it's a good idea to go ahead and triangulate your game model before you bake, so there's no possibility of topology getting in the way of your clean normals between different game engines. So basically, we just need to triangulate first so that the game model looks good in any game engine that it goes into. And we're going to go over our last topic. Sometimes you'll get slanted details in bakes, and I'll just demonstrate this real quickly with some pictures. So here we have a nice flat surface with some kind of, I don't know, cone shapes coming off of it. But you can see that they're slanted. They're just skewed. But this is not because we're looking at the normal map from an angle. This is because our normal map bake had some weird issues going on with it. So how do you get rid of the slantiness? This side has more information than that side, and no matter what angle you look at it from, these little cones are always going to be skewed. Well, if we put down some support edge loops, actually, on our low poly meshes right here, then that kind of clears up that slant. So see how the support edge loops around my block of wood here, or my purple piece of metal. I don't know exactly what kind of material this would be, but the support edge loops on the low poly come in handy here, and we get a nice clean bake. Notice how my cones now seem to be perfectly symmetrical all the way around. And again, if you can get away with it, you can actually go back in after your bake and delete these support edge loops on your low poly model, and hopefully your vertex count won't be messed up and your UVs will stay the same, but you'll get rid of some of that extra geometry you had to add to make sure that your slanted details went away. Okay, so that pretty much does it for most of the big no-nos with building a low poly model. Why don't we get into actually making our low poly mesh here? All right, so we're going to do a few things. We're going to make sure we have the geometry on my cylinder so I don't get the waviness. We're going to see how we can decrease the poly count by getting rid of unnecessary edges. And we're going to UV it. Oh, we're going to UV it with separate hard edge islands so you can get an idea of the UVing process. We'll also look at how we can mirror symmetrical pieces of our shape here, and we'll triangulate it before we do our bake. Then we'll get into the whole baking process inside of Maya. All right, so let's get to it. All right, so this is my low poly model. What I'm going to do is I'm going to bring up my high poly, and I can already see that I don't have enough geometry around my cylinder here. Let me get rid of some of these windows here. So I can do a few things. I can go in and try to make my own geometry here and just kind of wing it and move the verts around as I please. That seems like not such a great idea. I don't know. Why don't we try it? Who knows what I'm doing? I'm just putting down edge loops randomly. All right, I don't like that idea. What I'm actually going to do is I think I'll create a new cylinder with twice as many faces and just attach it to my low poly. That way I can get a nice, even, symmetrical ring of edges and verts, and I'm not just moving my verts around willy-nilly. So let's see how many faces we have on this cylinder. 1, 2, 3. Well, I guess we can use our heads-up display. So we have 12 faces, and to get to this heads-up display, we can go to Display, Heads-up Display, and then we're going to check Poly Count right here, and that'll tell us how many faces we have selected. We have 12 faces there. So if I go to Create, Cylinder, do 24 axis divisions, press Create. Then we just got to position it like so. I'll go ahead and scale it down. And I'm going to lock my low poly layer so I'm not messing around with it too much. Get rid of my high poly. And we're just going to kind of match it as close as we can to the original. You know what? I'm going to hold down D and V to snap my pivot to the very front of my cylinder, right in the center there. That way I can just snap it to the center point right there. There we go. And we can already see we're getting a little bit more detail around, and we're going to avoid that waviness. All right. So with that created, I'm going to select the back side of my face verts. I'm going to snap it flush in the X axis. Go into face mode. Delete these back faces. And now all we have to do is just merge verts. We might have to create some extra geometry. So we can do that pretty easily using the multi-cut tool. But I want to make sure of one thing real quickly. I want to make sure that my edges of my low poly are matching the edges of my high poly as much as possible. All right, so what I'm going to do now is, why don't I go ahead and I'll just hide that new cylinder I made for now. I'll unlock my low. And I'm just going to go ahead and delete this cylinder. And let's show all. There's my cylinder in action right there. I'm going to bring back my high poly now. And I need to make sure that this new cylinder is correctly describing the dimensions of the shape that I'm going to bake to. So I'm going to hide my low layer. So I just have my new cylinder and my high poly visible. And I'm just going to scale the cylinder so that it's really as close to the edges as possible here. You can see how we're kind of getting some intersections going on. That looks pretty good. And I think I might be too far forward. So there's my high poly edge right there, and there's that new cylinder's low edge, or the new low cylinder's edge. So I'm going to select my vertices, and I'm just going to vertex snap them up right on top of my high poly. So they're just right on there. Looks pretty good. So I've used some scaling tools to snap them correctly. I'm going to hide my high poly now. Now the task of connecting this new cylinder. I'll lock that down so I can just grab these. I'm going to make sure that I'm snapping the base of my cylinder to the exact distance that I want to merge to right there. And from here, it's just a matter of, I guess, snapping verts for the most part. And there's two ways we could have done this. We could have made the geometry for these pieces right here, because we don't have geometry to connect to this line right here. So why don't I go ahead and just do that? And since this is a low poly, I don't have to use support edge loops. I'll just go ahead and start making some triangles. No harm, no foul. And I'm not going to worry too much about the placement, because I'm going to be snapping them together eventually anyway, so no big deal. So I'm going to go ahead and pause this and finish up making this geometry. So I'm back, and I've created enough geometry around here. Now I have the exact amount of verts I need to be able to snap these together. So it's just going to be a simple matter. I'm going to go ahead and turn on vertex snap, so it's just a simple select and move. So I'm just going to go all the way around my cylinder now. Seems like a lot of work for just getting your cylinder made. You might have a better workflow. But by creating a brand new cylinder like I did, I know that my new cylinder I've created, is going to be perfectly round. It's not going to have any weird issues going on. And I'm going to go ahead and pause this again and finish snapping all these around. So an easier way that I found out how to snap those, I'm going to go on the inside of my model, go to wireframe mode, and just select and drag. And there we go. I now have a completely flush hole, like right there. And now I can combine my two models right here, mesh, combine. And then to merge the verts, I'll just select roughly all the verts in the area I want to merge. Hold down right click, hold down shift, right click, merge verts. Go to my extra little option menu right there. Make sure my threshold is really low, because we only want to merge verts that are right on top of one another. Hit apply. And there we have a flush model with a nice cylinder that's going to make sure our waviness isn't going to be a big deal. So that's perfect. Now the next thing we're going to do is we're going to make sure that we don't have too many unnecessary faces and triangles going on here. All right, but before I go ahead and just start turning this original model into a low poly, I'm going to be doing a mirror duplication anyway, right? So why would I do a bunch of extra work on one side of the model that I'm not going to on the other side? All right, so what I'm going to do is I'm going to delete half of my model here. All right, boom. Now I only have to worry about making a low poly on this side. And there's a few ways we can tackle this. You can use the target wheel option right here. So you just click and drag and just, it becomes just a simple, getting rid of all these extra little verts here. This is kind of a new tool, I think, introduced in the last few years in Maya. It's pretty good. Notice how we're just, snapping vertices to one another. And the target wheel will snap them and automatically merge them. Nah, I don't think there's, I would rather go up here. What you want to avoid are like some really radical triangles being stretched. Let me see if I can make one. I've kind of already done all of it. But when we merge our verts, we don't want our triangles to be so severe. So that's a good example. See how this triangle is really sharp and narrow? You want to be smart about what we're doing here. Now we don't have sharp, narrow triangles. That's kind of getting close here. So maybe if I brought this one down to there, that's a little bit better. The triangle is not as sharp anymore. There we go. And we're just getting rid of detail. We don't need these. And the rule is you're really just worried about the silhouette of your model. All these extra details, they're just flat. They're not doing anything. Get that rogue vert out of the way. So we're just focusing on the silhouette. Like so. And even this right here, looks like it could be fixed. There we go. And why do I get rid of that one? Well, that's creating a sharp triangle. So maybe if I go up with this one, that's even sharper. So I think I'll just let that one be. I'll have a little bit of extra geometry right there. I don't want to have really small triangles. And looks like we're going to get rid of this geometry up here. Notice how the overall shape isn't changing. We're just getting rid of just unnecessary verts all the way around my model here. So it looks like we have some lines. Looks like we can get rid of these too. All right. So that's looking good. We already have a nice triangle pattern right there. And we're getting some normal smoothing errors going on right here. But we'll just do a hard smooth. I'll turn off that. We'll apply hard normals right there to our edges. And then I can just select these edges on my cylinder and apply a soft. And there we go. We've successfully created a low poly model using my original model that I used the shape on. And since we're basically building our high and low out of the same original model right here, we know that all of our edges are going to line up and everything's good. So why don't we get to UVing this guy now? All right. So we're just simply going to UV him real quickly. So I'll bring up my texture editor. A lot of junk going on right here. This is not a happy model. So I'm just going to grab all the UVs over here, and I'm assuming you have basic UV experience inside of Maya here. So I'm selecting all the UVs and just getting them out of the way. I don't want those trash UVs to pollute my one-to-one space. And I'm even going to turn off this gray box right here so I can see my one-to-one space more clearly. All right. So we're going to go ahead and we're going to just UV one side of my model here. All right. So I'll select this face. And I'm going to be just using some automatic mapping. I'm not going to worry about planar or anything like that. In fact, let's see. What kind of considerations do we have to make here? We go to my edges. I can see that there's hard edges pretty much everywhere on this model. I'm selecting all the hard edges. And remember, anytime there's a hard edge on our low poly, they have to be on a separate UV island. Rule of thumb. So it looks like we're going to be creating a lot of different UV islands here. So I'm just going to see if I can select all of these together. Maybe this will be quicker if I just select all the 90-degree information. And if I go to UV and go to my automatic mapper and set my planes to 6, we should get a pretty decent projection already made for us. See how it's nicely already laid out there? And it's done the pleasure of already making separate UV islands. So if I select one UV, I can hold down Control and right click, go to Shell. Now we have all the UVs selected on that particular island. And then if you want to see the face that it corresponds to, I'll hold down Control, right click, and go to the face. And it looks like, yeah, we have a nice UV island for this particular square right here, for this particular face. And, these 90-degree angles and these hard edges, it's just creating a bunch of different islands here. So the automatic mapper really came in handy here. All right. So I'm not ready to pack these yet. I've got them just laid out perfectly, so I'm going to kind of move them over. So whenever I do a projection map right here, the best way to handle this cylinder, we could use the cylindrical projection in our UV, but I'm going to cheat. I'm going to look at it pretty much straight on, go to UV, do a camera-based projection, and it's skewed here. If I go to polygons and just unfold it, wow, we get the cylindrical shape gets unfolded nicely, and Maya even took the pleasure of packing everything for me. But this packing is just terrible. There's no space in between these UV islands. You want to add a lot of padding on the borders of your UV map right here. So what we'll do is we'll use a tool that will hopefully pack it a little bit easier for us, something to automate it. So I'm going to go to polygons, and I'm going to go to layout. This is in my UV editor. And I'm going to make sure the settings are just the way I like them. We don't want overlapping UVs, so we want single and multiple objects non-overlapping. World scale looks pretty good. We're going to pack them into the whole region here, the one-to-one region. We want the scale mode to be uniform. We don't want stretching. We want to make sure that our UV islands are indicative of the shape they make in 3D space. Yada, yada, yada. We only want to rotate. I guess that doesn't matter too much. I mean, we could do free and they'll just be rotated any which way. But for the texturing process, this is make sure they're all 90-degree laid out. But here's the shell spacing that really is handy. If you go to custom, we can set up our own kind of spacing here. And percentage of space will dictate how far away they're all spaced out. And then this region preset makes sure that our layout isn't going to put our UVs directly on the edge of my region right here. Because remember, our one-to-one region in our UV space just repeats itself. So basically, this little negative space right here, this nothingness, it's just going to repeat into this. And now we have this edge right there and that edge right there just bleeding into one another. So we want to have a border ring of space around our one-to-one space. And these settings right here do a pretty good job of making sure that we have that border space around our one-to-one. All right, so with our model selected, I'll just hit Layout UVs. And now you can see that I have border space around all of my UV islands here. I could pack them a little bit more intelligently, but I'm not going to obsess over it too much. All right, so I'm already seeing an issue that we're going to run into. We're not completely symmetrical, right? This little cube popping out on the left side, if I go ahead and do a mirror, that's not the kind of detail that we want over here. Well, why don't we tackle that when we come to it? We'll take care of that. So what we're going to do now, and I haven't looked at my outliner lately. I want to see what's going on with it. All right. So now's a good time to delete my history. So that's what we're working with, P cylinder 2. I guess that's a terrible name for that. We'll call it low mesh 001 for now. And why don't we go ahead and mirror duplicate it over. Control D, and then I'll do a -1 in the scale Z over here. And for all intents and purposes, I got a nice mirrored mesh right here. So you can see that my UV is on the left side of my mesh that I spent all the time UVing. If I select the mirrored duplicated side, the UVs are exactly the same. They're laying right on top of one another. All right. But I got to take care of this right here. I got to delete these faces because this is not the shape that I want here. So what I want to do is I want to go ahead and just fill this hole up like so. I wonder if I can get away with doing something like this. Nice. So I just got rid of all that detail there. And I'm going to select this vert right here. And I'm just going to do a merge to center. Go into sub D mode, making sure I'm not missing any faces. Looks like I'm got a weird little face right there. So we need to fix that. I'll actually undo all that work there because that wasn't the smartest way to revitalize that. Why don't I just go in and delete the UV or the edges? I can figure out how to tackle this face without making an end myself. Multi-cut. Why don't I just terminate it like that? There we go. Now we're not getting any hidden faces or anything going on. But what we do have is a brand new face, like so. And it needs to have its own UV space, believe it or not. All right? Because right now, our little floater is going to be drawn here. That's a ring floater. And it needs its own UV space. Otherwise, it's just going to get a duplicated, weird-looking box thing on this side. So I'm going to select this face. I'll go to UVs, and I'll just pull it out for now. All right. So now is a good time to show how we can shift our UVs over one space or one unit of space from here to there. If I go into my outliner, let's see, I know I have the script written in here somewhere. There we go. We go to mirroring UVs right here. This line of code right there, that mel line of code, I'll just Control C, copy it. And then with this model selected, I'm going to go ahead and grab all these UVs. I'm going to come down to this mel line. If it says Python, click on it, it'll turn to mel. Control V and hit enter, and boom. I moved over all my UVs 1 units of space. Now I need to figure out how to get this face on its own unique place over here. So I just think that's a matter of, I don't know, maybe moving these boxes somewhere new. And I'll scale them like so. This is my little outset box going on, leaving plenty of padding. So the auto UV layout wasn't perfect for us because we had this extra little bit of detail that we had to manage. So I'm going to pack them just right, like so. And then I'm going to take this in, and I might need to scale it just a little bit. I'm not going to worry too much about it. Packing job is a rush job, but this isn't a UV tutorial. The main thing I'm just focusing on is enough edge padding, like so. And looks like I don't have UVs for the front of this low poly. So let me make those real quick. I'll do a UV, and I'll just do an automatic map for that. I need to select all of this. I need to find a place for this. So we'll do this. Why don't I just... But here comes another teachable moment. I don't have UVs on my mirrored side now. I have UV'd my original side, but who's to say they're going to match up over here? Well, looks like we're just going to have to do a little bit of tweaking here. So I'm going to select my mirrored duplicated side. I'll go into component mode, so I'm not selecting those extra faces. I'll delete those, and then I'm just going to go ahead and duplicate this side again. Do another -1 over there. So now we have two mirrored sides resting on top of one another. So that's not good. But what I want to do is I just want to isolate the duplicated cylindrical face, and I'll delete everything else. Now we have my cylinder doing its thing. We have the front of my cylinder mirrored perfectly. So there we go. They're right on top of each other now. All right. Now that we got through that disaster, we've salvaged our UVs. We didn't have to start over. All right, great. It's looking pretty good so far. All of my hard edges have their own UV island. And I think we're done with the UVing process. All right, cool. All right, so now all we got to do is triangulate this bad boy. But before that, I'm going to combine them all together and make this just one mesh. We'll do a combine. I'm going to bring up my outliner. I'm using a lot of different shortcuts on my custom shelf, but you guys will get the idea. I'll delete all by type, get rid of all that history. We have an extra group kind of just left over. Low mesh 001, we'll rename it. And now all we have to do is merge the verts, merge vertices with a low threshold, and we'll hit apply. And looking pretty good. We've got a low poly made. We've got our UVs mirrored duplicated to the other side. We got more geometry on our cylinder so we can get rid of the waviness. And I think we're ready to call this low poly mesh done. All right, so let's continue with my baking process. So before I even get started with bringing up the rendering or transfer maps tool, I'm going to prepare my models and organize my scene a little bit more. That'll help in the long run where we're applying our different meshes to do their dirty work in our baking process. So I can get rid of my texture editing screen. So here's my tutorial group, and there's my low mesh. I'll go ahead and parent it under my tutorial group, and I'll make sure it's on the low layer, like so. And what we're going to do is we're going to duplicate my high mesh. So I'll hide my low, make visible my high layer, and I'm just going to duplicate it. All right. And I'll take my duplicated high mesh 02 right there, and I'll remove the selected objects from it so I can hide my original high mesh. And what we're doing is we're making a duplication of my high mesh because now we're going to apply the smooths to it. Now we're going to kind of finalize the geometry going on here. So first I'm going to select all my different pieces here, and I'm just going to do a mesh combine, and I'll delete all my history. So now we just have a high mesh. Let's call this smoothed mesh 01. And I'll parent it back under my tutorial group. And with smooth mesh 01 selected, I'll go to mesh and I'll smooth it a few times. I'll hit G, keep doing it. And there we have my smooth mesh, and I can even create a layer for it. Maya's bugging out on me. Sometimes my Maya's bugged. It won't let me create new layers sometimes. Oh well, we'll just deal with it. For right now, I'll just use this low layer wrong and call this smooth lay. And I'll assign it to a smooth layer. So now I have a smooth layer, a low poly layer, a high poly layer with my geometry still intact. It's just got my support edge loops on it. And I still have my original model that we all started from. Handy sometimes if you ever make mistakes and you need to start over, you have your original mesh still there waiting for you. But we're going to be looking at our smooth mesh and our low poly mesh mainly right now. So the next step is to, and I'll keep my outliner visible because I'll probably need it to select exactly what I need. We're going to go to rendering tool set now. So in our drop down menu, we'll go to rendering. That changes my options up here. And we'll go to lighting and shading. And we're going to bring up my transfer maps window. And this is what we get right there. All right. So my transfer maps window is where the magic happens. I'm going to go ahead and reset all the settings so we can start fresh. And I'll just collapse all the different options and we'll go through them one at a time. All right. So we need to start assigning different meshes, our target mesh and our source mesh. All right. So let's just focus on our low mesh for right now. So I'll select my low mesh in my outliner and I'll expand my target mesh. And this is going to get a little bit weird, but bear with me. I'm going to, with my low mesh selected, and under target meshes, I'm going to add selected. And we see that we have tutorial low mesh 001, tutorial being the name of the group it's under. We're going to do something weird here. Where it says display, we're going to go and call it envelope. What does that mean? Well, right now we're going to set up our projection cage. We're going to create a big pink model and we'll hide my smooth. What the heck happened? If you look at my low mesh over here, with this envelope option selected, I've hidden my low poly mesh right here, and it's created this brand new game object called shape1 envelope. And what this does is this pink cage right here is actually where we're going to start projecting our normal map bake from. Think of the inside of this pink shape. That's just 1,000 camera lenses or 1,000 eyeballs looking into whatever's contained within this pink little cage. All right. It's basically just where the rays of the projection algorithm are going to project from, where our normal information is going to be projected from. So it's basically our normal bake camera lens. I don't know how else to describe a projection cage, but basically this describes a shape where our normal map bake is going to start from. All right, and with envelope selected, we get to actually go in and tweak our envelope, our projection cage. All right, so it's kind of a little bit of a nice tool Maya gives for some fine tuning of our normal map bake. All right, and then our search envelope, it kind of allows us to inflate or deflate our envelope, but since we're modeling this by hand, it's not going to really be used. All right, so we'll get back to my pink envelope projection cage right now. And why don't we bring back my outliner? And I'm going to select my smooth mesh. And I'm going to go ahead and make my smooth mesh visible and lock it down. It doesn't matter if it's locked, but I think it does matter if it's visible. So make sure you do that. Now I'm going to expand source mesh. And with my high poly smooth mesh selected, I'm going to add selected to that. So now Maya knows what model I'm going to project onto with the target mesh, and it knows, okay, what kind of details am I going to project onto my target mesh? Well, it's going to be my high poly smooth mesh 01. All right, now's the good time to make sure that our envelope is doing its job. And this is going to come in handy. I'll minimize some windows for the time being. This is going to come in handy for anytime that you have maybe some floating geometry, extruding or offset quite a distance away from your low poly, what I'm going to do is with my envelope selected, I'm not editing my low poly game model right now, just the projection map that it's projecting from. I'm going to kind of bring it out and make sure that it's kind of encapsulating that floating geometry. And I'm going to do the same for the backside here because my little button protruding off of my high poly mesh, we're going to just make sure that the cage sees it. All right. And for the most part, my edges are lining up okay everywhere else, so I'm not going to be too concerned with that. I'm just showing how we can tweak our projection cage just to make sure we're capturing all the information we have here. And there's another way to compensate for that, and I'll explain that in a second when we get to that option. So I'm going to bring up my transfer maps again. And this time I'm going to expand output maps, and I get to select what kind of map I want to bake from. Maya gives us a lot of different options here. We can create ambient occlusion maps, we can create displacement maps, but we're mainly worried about normal maps since this is a normal map tutorial. So I'm going to click normal, and it gives me a few options here. The main thing you want to adjust for is where you're going to save it to. So I'm just going to save it to my desktop, and I'm going to give it a file name. We'll just call it normal map. You can be as specific as you want to. Maybe something that, if you have like a character name, give it the character's name and then the underscore normal map, just so you know exactly what normal map it goes to. And we're going to go to file format, and I like baking out targas. That's just my favorite file type. They work really well in Photoshop. They retain alpha channels and they're lossless information. Pretty much everything else, use Maya common settings. So now we have to make a decision. Do we want to use Maya software to render our normal map, or do we want to use Mental Ray to render our normal map? Both are solid decisions, but I'm going to stick with Mental Ray, so I'm going to uncheck Maya common settings. And just to make sure, I don't know if this is going to matter or not, I'm going to make sure that we're baking out the right size map. We're going to bake out a 1K map, 1024 pixels by 1024 pixels. We'll keep the aspect ratio checked. And since output connect maps, this basically says, do you want to create a new shader in your hypershade? So after we bake it, Maya will create a new material and apply the normal map directly onto our target mesh. I kind of like leaving it checked. It allows you to double check your work directly after the bake. So if you're using Maya common settings, then you would tweak these values right here. But since we're going to use Mental Ray, I'm going to go into Mental Ray, and again, I'm going to input the right size map I want, 124 by 124. And I'm going to come down to number of samples. The more number of samples you use, the higher quality the normal bake, but the longer it's going to take. So I'll just do something like, I don't know, I'll do something like 10 right now. And I'll just pause it whenever we're baking it so we're not just sitting here. And I'm going to make sure fill texture seams is set to something. This is our edge padding that overdraws on top of our textures. Remember, you want always to overdraw on your UV island borders. I can bring this up. We want my normal map to project over here on my border and then some, so it'll kind of overlap by a few pixels. Because in game engines, you always want to overdraw your textures because bitmaps and distance rendering and one-to-one voxels and texels, whatever. There's a lot of reasons why you have to do it. Otherwise, you start getting seams in your game engine from various distances from your models. All right, so I'm just going to leave a texture seam at 1. Let's see what it gives us. If I don't get enough of a texture fill over the seam, then you'll know that you should probably adjust yours a little bit more. Advanced options. What we're going to do is the search method right here. And here's where the consideration for my projection cage is going to come in. Right here, we kind of manually adjusted our projection cage. And it kind of tweaked where we're going to be projecting our normal maps from. So In other words, we kind of messed with our search depth a little bit. If you didn't want to move your projection envelope at all, you could have just increased your max search depth right here. So I'll just increase it to about 5, and I'm going to bring back out my envelope. And we're going to do closest to envelope. You can do a few settings. You can just project anything inside the envelope. So if you wanted to really tweak your projection cage, you could basically just, I don't know, maybe scale it up a little bit. So everything inside is only anything inside the cage is captured. But that's a lot of unnecessary work for a model simple as this. So we're just going to set it to closest to envelope. All right. And we're going to match geometry normals for this particular bake. All right. So I think that does it for all the settings that we're going to do. So what I'm going to do next is bake my normal map, and I'll bring this up, and I'm going to delete all of these little windows right here because our progress is going to be displayed in our bottom left hand over here. So if you have windows up, it kind of blocks your progress, so you don't know if you've stalled or if it's making good progress. So I'm going to go to and press bake, and you can see my progress bar. Oh, looks like I must have a pretty fast computer, huh? And there we go. So to see your results, I'm going to hide my smooth layer and press 6. And there's my new normal map baked on my newly created low poly. And everything's looking good. You want to make sure. Looks like we got a little bit of artifacting around there. That might be due to sample size. So if you find any errors going on, maybe like right there, for example, I can always bring up my high poly. And it might have been just the sample size. It could have been that I didn't have the edges directly drawn where I wanted them. So let's see. Yeah, it might have been that my edges weren't directly on top of there. But for the most part, I'll hide this again, bring up my texture. For the most part, they're pretty seamless. A little bit of tweaking there. I won't do it for the sake of the video. I think if I just match the normal edge normals a little bit closer to one another, not the edge normals, but the actual physical edges of the intersecting geometry, that would have worked better. So matching your edges. I hardly have any waviness in the end of my cylinder right there. So that's looking good. As I pull away, my normal maps are working from a far distance because I added that extra organic, I exaggerated the smoothness of these angles right there. And I got a pretty good bake. So where is my normal map? Well, I think I saved it right here. So I'll bring up Photoshop and we'll just see what my actual normal map looks like right now. Looking pretty good. And if you have any kind of weird artifacts going on in here, you can actually see how they're working for my normal map right there. But just by looking at my normal map, I'm not seeing much here. I want to actually take my UVs and do a snapshot and overlay on top of my normals so I can see how they're working out for me. So I'll select my low poly mesh. I'll go to polygons. I'll do a UV snapshot. I'll save it to the desktop and call this UV snapshot. And I have to set the file size or the dimensions, the pixel dimensions. 124 by 124 is what I was baking to. And I'll save this as a targa as well. I'll hit OK. Now we have a UV snapshot there. I'll open it inside of Photoshop. And I get something like this. So what I'll do is I'll flatten this layer. Control A to select everything here. Control C to copy it. And then I'll flatten this background layer there. So we have my normal map on layer 0. I'll Control V just to slap my UV snapshot on. I'll go to Image, Adjustments, Invert it. So now we have a predominantly white UV map. And then here's a nice little trick. If we go to Normal and set it to Multiply, we can now lock it. And now we have my UV snapshot projected directly over, or overlaid or multiplied directly over my normal map. We can start seeing, that's a little bit of an issue right there. Something we can always fix later. All right, looking pretty good, and that's what my normal map's looking like right now. So if we go back into Maya, I'm happy with everything. All right, great. So let's talk about the boot camp assignment. So what I'm going to give you guys is the original tutorial scene that I just made, complete with the map that I baked. So I'll give you this normal map that I baked, and I'll give you, you can walk straight through, the whole tutorial baking something that's already kind of made out for you. So you can just get a handle on, setting the search envelope and going through the steps of, bringing up transfer maps and all that. So you'll have the high, low, smooth, original all made for you, just so you can get a better feel and start from a, square one basically with your trials. So you're gonna rebake your own normal map from the tutorial video. So I'm going to see your own baked maps from that. So that'll be your first bullet point, your first deliverable for this assignment. All right. I've also included 2 other files for you. So if I navigate here, so what I've given you here is a simple spaceship, or it's like a cargo barge. I call it the barge spaceship. It's nothing too glamorous. I've given you a original model, so it hasn't been UV'd, it hasn't been turned into a low poly. So it'll be up to you to create a low poly model from this and UV it correctly. And I've given you the high poly as well. Let me put that on original. I've given you the high poly version of this as well. So you're not technically worrying about creating the high polys here. It's not a modeling lesson. Mainly what I want to teach you guys is how to create the low polys necessary for map baking and how to UV those and how to actually bake the maps. So what you're going to be doing is baking this high poly detail onto this original model by creating a low poly. And I've given you some resources to do that. So if you look in some of the included pictures, what we have is a color-coordinated breakdown of the model, and that corresponds to this example UV sheet that I originally baked my final product from this model from. It's kind of a cheat sheet. You probably won't be able to get I don't imagine you should exactly follow this UV layout, but it gives you an idea of where I make splits at hard edges and what parts of the model I separate into different UV islands. So for example, this magenta to cyan, there's a hard 90-degree angle right there, and you can see the cyan and magenta, and it just goes all the way around this little office space. There's the green side, which corresponds to this UV island. There's the magenta backside, which corresponds to this UV island. So it's just giving you guys kind of an idea of what parts of the model I separated into their own UV islands. And you can even see some splits I make on those UV islands. Say, for instance, this is the bottom of my barge. This is the back right or so corner. You'll notice that there's a hard 90-degree angle there. So, the rest of it's at a kind of an angle. So there's no 90-degree angles except maybe around the corners here. So I just simply separated those edges, and I was able to keep a continuous UV island by just splitting where I needed to on those hard edges right there. All right, so I've kind of given you a head start with that. I've also included a few pictures of my normal bake that I got from this, and then I kind of give you a sneak peek of how I used Endo 2 and a few other programs to add more detail on top of that. So I got a nice starting bake, and then I added some superficial detail. So this is the regular bake I got from just this map right here. Notice how we have some nice smooth edges around here. This is with the detailed normal map. applied there. And here's my splash page for my final model of the ruins here. Or the ruins was the name of the level. I guess at the time I called this platform, but I call it the barge now. It's a nice, simple kind of model to help you guys get more familiar with the normal map baking process. So that'll be the second deliverable. All I'm looking for is this right here and that map right there. I'm not expecting you guys to add any of this detail. I'm just showing you what's possible by getting started with a high poly bake and then use another program. You can add really crazy detail to these guys. But it's all started with a nice normal bake, like so. All right. So the third file you're going to be working with, and I'll go ahead and save this because I think I made some changes. And the real test of your skill, boom. This is going to be haunting. So here's my original model for this. Can I create a layer? It's not letting me create layers still. All right, so here's my original. Now let me bring up my outliner. All right, and you'll notice I have 3 separate meshes in my original. So your goal will be to duplicate the original and call this low group. Remember, you don't want to destroy your original. And then with these 3 right here, you'll be making the low poly from it, adhering to the various rules you're already familiar with at this point by now. And then you'll UV it yourself. And then a new kind of situation occurs that we didn't talk about yet. We have models or separate pieces of geometry inset with one another. So the way you'll actually bake that is you'll explode the model. And I'll show you how to do that right now. So we'll go ahead and show my high poly and my low poly. All right, I'll unhide these. So what we're going to want to do is we're going to select all the pieces of geometry from my low and my high poly smoothed. And we're going to come down here in my timeline, and we're actually going to keyframe by pressing S their position. And then we're going to go up the timeline to maybe around 65 seconds, whatever. And I'm going to select each corresponding piece. So my gun mesh, original, or I guess I should say low at this point, and smoothed. And then I'm going to pull it up. Let me hide my original. So I have my low and my high poly smoothed right on top of each other. Actually, you know what? I should have done this first. There we go. That's right. I had it right. So we have all of my meshes. Yeah. All of my meshes, even though they're in groups, are keyframed at frame 1 in their original positions. We'll come up to like the 60th frame. I'll select my smooth gun mesh 001 and my low gun mesh 001, and I'll move them together. And that's my original being left behind. And then I'll keyframe them there. All right, so now I have 2 positions on my timeline of them in separate positions. I'll go ahead and hide the original like so. And then I'm going to do the chambers and go back to around 60 seconds there and keyframe them down here. And then I'll do the triggers the same way. So this is what we get. At frame 1, my gun is completely put together. But as I go on my timeline, my high and my low travel with each other. I'm exploding my model. This is because during the normal map baking process, you want to have ample amount of room on all your pieces of your geometry. So, this could be a nightmare trying to project these 2 at the same time. You'll have overlapping details, and it's gross. So exploding your model like this, that's the way to go. Now each piece of geometry has their own space to do their thing. All right. So that's only after you have UV'd and retopologize your low poly model. All right, that's basically you do this right before you bake. I just wanted to give you guys a heads up on this little method. So yeah, the gun will be your final test on, you know, how you will do this. So there's a lot of different geometry going on here that's pretty tricky. Um, remember, these edges right here, this edge loop right there, it's not 90 degrees, all right? It's kind of beveled right there. So you wouldn't have to separate this on a UV island. You'll still probably want to harden the edge. I'd still harden the edge, but since it's not a 90-degree angle, you can keep that on the same UV island. But yet you go up to something like this little guy right here, all these edges right here, all the edges I have highlighted will have to be on hardened and have to be their own separate UV island. So these faces would be their own UV island, that face would be their own UV island, and these surrounding faces would be on their own UV island. By the end of this gun, you're going to have a lot of separate little UV islands floating around. That's just the way of modeling. That's just the way of normal mapping. There are tips and tricks that are a little bit more advanced, but I want you guys to kind of adhere to these simple techniques. For the most part, the techniques I've gone over are going to be the ones you're going to be using forever. I don't know. Maybe I should demo a quick little way to get around having to separate all these UV islands. Remember how right here, even though this edge we want to keep hard, but we didn't have to put on a separate UV island because this angle right here wasn't exactly 90 degrees. Well, what if you came on your low poly model like this and, I don't know, beveled your low poly model to something like, I don't know, 0.05? All right, let's zoom back into what we were working with. Now all of a sudden, you don't have a 90-degree angle, but you are left with a little bit more geometry. So pros and cons, right? Because I don't know if I mentioned this before, but the more UV islands you have on a model, that kind of ups the hit it takes to the frame rate. So the more UV islands you have, it's kind of like having extra geometry anyway. So it's just a matter of preference. What we really just want to avoid are those seams being drawn at 90-degree angles on those hard edges. So adding a bevel gets rid of that 90-degree angle, and pretty much this whole thing right now can now be on its own UV island. All right, that can be one complete UV island, but yet this will still have to be on its own. So hopefully that makes a little bit of sense. So that's just a little tip and trick. So that's basically what I'm looking for. I'm looking for a normal bake on the tutorial cube and cylinder shape we worked on. I gave you the cheat sheet for the barge that kind of shows you the UV layout I had for it. And you're going to go completely cold into building and baking out this gun right here. And remember, before you bake and after you build your low poly game model, you're going to want to explode the high poly and the low poly together so they get their own space to bake in. And then after you're done, you can just bring them back together and they're in their exact same original spot. So those three things what you're going to be tackling for this chapter. Again, make sure you refer back to the outline. There's going to be hyperlinks inserted here that'll take you to every section of the video here. So if you need help remembering the hard edges and UVs, that was at 40 minutes and 32 seconds, and you'll just be able to click a hyperlink and it'll take you directly there. All right, guys, this is the big boy stuff of modeling. A lot of considerations being made, and this kind of separates the people that go and make modeling their career versus the people that are like, you know what, I think I just want to be a designer or a programmer. Normal map baking breaks people pretty much. But at the end, when you get nice clean bakes, it's totally worth it. It totally works pretty well. And if you guys want to go ahead and see some of my results for my shotgun, I'll bring them up for you real quick. So you can see this is my bake for my gun here. And I'm not going to give too much away, but I was able to capture these normal maps here. And more thing I want to point out, you know, the gun is such a good model to practice on because you go from, you know, hard edge modeling, hard edge sub D modeling, and then you transition into this more organic gun handle shape that we got going on right here. So you'll notice how the gradients are really smooth and hardly, there's no real gradients on this normal map. But then when we get to the handle, the more organic shape, then we start seeing these subtle gradients that are perfectly fine, but it's just the nature of the beast when we go with more organic shapes here. So being able to transition from, the hard surface modeling to the organic shape of the handle, that's a really cool exercise. And there's my diffuse map and there's my spec map. And this is the result I got. So if you set yourself up, you can get some pretty cool results out of this. And this is kind of a cartoon looking, I don't know, Borderlands like gun I was going for. So not quite fully Borderlands style, but close enough to it. I was happy with the results. All right, guys, this video has gone on for way long. So refer back to the outline if you get lost, and good luck with your baking.